Welcome to mechanical tutorial. I am going to teach you different techniques in SolidWorks for mechanical engineers. I am going to train you different modules like surface modeling, sheet metal and enclosure design, product design, plastic components design, reverse engineering and many more tips and tricks in SolidWorks. Hi, today I am going to explain about joist hanger. So this is the component. So this component is mostly used for supporting the two perpendicular wooden blocks. So this is the component looks like. See, this is the component. So I am going to show you how to create this component in this video. And the sheet thickness is 20 gauge, that is around 1 mm, and the material is galvanized steel G90, and these are the dimensions. I am going to share you this PDF. Please check link in the description. In next video, I am going to explain how to create the dimensions of this component and how to place these views and how to write notes on this note for these components. And this is the flat pattern dimensions. So I am going to show you how to create these dimensions also, and how to place hole table. So instead of giving every dimension for these holes, which becomes clumsy, so we can create a hole table. So I am going to show you this, and I am going to show you how to place flat pattern in a blank sheet to create into DXF file for laser cutting or blanking of this component. So let's start now. Take a new part file. Select the top plane. Go to sketch. Take center point rectangle. So dimensions are 51 by 76. Go to sheet metal. Go to base flange. Take thickness of 1 mm, and here I have taken K factor as 0.45 because the galvanized sheet is having 0.45 as the K factor. So say OK. So now I am going to create the side flanges. And keep it in front plane and make sure that the outer edge of the flange should meet this edge. So we have to go for material inside option. So I say OK. So we have to constrain the sketch. Go to edit sketch option. Keep it normal. Go to smart dimension. Select the outer edge. So we have to give dimension from outside edge. So take 120, say OK. So we have to modify this second flange sketch also. So for that, what we have to do is keep it in normal plane, go to view, hide options, uncheck all types. Here we can see the sketch of the other flange. Select these two lines, make it collinear, because when we modify this flange, automatically it updates in the other flange. So that is how we have to do for symmetrical flanges. Now select right plane, go to sketch, keep it normal, keep it in wireframe. Here take inner edge, convert entity, and here the outer edge, convert entity. So we can identify now. Draw one line vertically and one slanting line joining this point. So simply drag this point to other side. And draw one more line. So if you convert this line into entity, it exactly matches the bend line. So when we update any flange height or the sheet thickness, automatically this line updates according to convert entities. So that is the advantage. Now go to trim entities, go to corner trim, select these two lines and these two lines. This distance we can give any value, so I am giving 2 mm. So this is 35. So this is the cutout feature. So that's why we are giving from this outer dimension. So this is going to be material. So this is going to be material now. This is 45 degrees. So sketch is constrained now. Now go to sheet metal, extruded cut, go to through all both sides. Say OK. So this material is removed now. See here. Now I have to create this side flanges. So go to sheet metal, edge flange, select this edge and this edge. Say OK. See, we have an angle at this location. So that is 55 degrees. Initially I am going to modify this flange, the right side one. Select this line, remove vertical constraint and just simply move inside. So this is 55 degrees. We have to give dimension from outside edge. So this value is 35. Say OK. So we have to modify the other side also. Keep it normal. See, one thing we can do is, we can see the sketch. This is a sketch line. So select the sketch line and select this. Make it equal. And this line. Make it equal. And this line and this line. Make it equal. So it is constrained now. So it forms symmetrical flange. So when we update this right flange, automatically it updates the other flange also. So that is the advantage. Now we have to create these cutouts. Go to unfold option, select this flat face, collect all bends, say OK. Select this face, keep it normal. Keep it in wireframe. Go to sketch. Select this face and go to sketch. So we have to create 4 rectangles. 2 from this end and 2 from other end. Remove the coincidence. This is not going to meet here. See, I have created all the dimensions of this cutout. Now select all the entities of this cutout. Go to mirror entity and select the center line. Say OK. Go to sheet metal module, extruded cut. Here we have to always link to thickness. That is important. Go to shaded form. Now we can fold this component, collect all bends. Say OK. So the cutouts are created now. Now I am going to show you how to create these holes. So roll back to the cut extrude. Select this face, keep it normal. Go to sheet metal and select simple hole. And say OK. Now go to edit sketch. Keep it in wireframe. Now I am going to create all the hole features. Hole is 4 mm diameter. So this is 8. This is 20. Select this hole. Go to linear pattern. So flip the direction. Distance is 30. And we have to create 4 holes. Say OK. Now here also we have to create one circle at the center. Make it equal. Now we have to create from other direction. This is 12.5. This is 10. Select this hole and this circle. Make it equal. Now we have to pattern this circle. Select this circle. Go to linear pattern. Flip the direction. This is 30. And we have to create 3 holes. Say OK. See, this distance is 20. Now create one more circle. Now we have to pattern this hole. So select this circle, go to linear pattern, flip the direction. These are 5 holes and distance is 22. Say OK. Take one center line, draw vertically from the origin. Now select all the holes. Go to mirror entity, select the center line. So it is created symmetrically. Say OK. go to shaded form. See, these holes are created now. Now roll back to flat pattern. This component is ready now. Now we have to add fillets, these fillets. So go back to the unfold state and go to break corners. So we have to select all sharp edges. So this is 3 mm. So you can see here I have selected all the sharp edges. Say OK. Now once again we have to go to sharp corners. Select these two corners and this is 10 mm. Now roll back to flat pattern. So the final component is ready now. You can see the flat pattern. See, in flat pattern sketches are visible, so we can hide all the sketches. So this is how it looks like. So this is how we create this kind of components like joist hanger. In next video, I am going to show you how to create this component drawing with notes and how to create this flat pattern and create whole table. So this is brief about joist hanger. Thank you very much.